Alright folks, so we're finally going to get to do a capacity test, at least as much as possible, with these batteries got built here. Finally got them down here, and if you've seen some of my previous videos, kind of saw ready to build these. So I guess they're kind of milk crate batteries, I guess you'd call them, but best thing I found to put them in anyway. Seems pretty convenient, easy to carry. I have them down here for a week or two now, and they sure seem to be in the realm of pulling their capacity, as far as I can tell so far. But what I'm doing right now is I got this 24 volt battery charger going that I showed in the previous video. It's still pegged at 40 plus amps. The meter only goes to 30, but it's pegged, and it's putting in almost 40 amps there on the Victron battery meter, and it's getting pretty close to full charge. Got about 20 amp hours to go, so about 30 more minutes. And so what I'm doing here with this voltmeter is I'm keeping an eye on the voltage across the battery leads here. So the main positive is right here. Get that focused maybe. The main positive is right here, and the main negative is right here. So I'm measuring that with this guy, and this Victron obviously is measuring the voltage on the other side of the BMS down here. So when this voltage drops off, that means at least this one's fully charged, and I'm going to check this one once that's complete. That should be, I'm not sure which one will go first, but I've got another voltmeter here, but it reads too high to really tell much what's going on. So anyway, I'm going to see what happens here, but just getting charged up to do a capacity test. So once I get these two batteries charged up, I'm going to discharge them at the same time and see if I can pull over 5 kilowatt hours. If I do, I'll be a pretty happy camper. But I'm going to charge these up fully, and then I'll unhook this bank, and this guy down here, and just run our system off of these two batteries. And so the charging voltage on this guy is like 28.4 volts or something like that. So it's not fully charged, but it's pretty close. And when I did check this BMS, but both of these BMSs I bought for each of these batteries, they do cut off the voltage when one of the cells gets too high, which is good. That's what they should do. But I haven't tested them on the low end. But I don't think I'll get down to where the BMS shuts these off. I've got this inverter charger set up to turn on the charging function at 23 volts right now. I think I might lower that here for this test. But that's what I got set up right now. So we'll see what happens with that, and I'll give you an update here when these get charged up. Alright folks, so this BMS shut down just a couple minutes ago. Unfortunately, we're only at 27.6 voltage. We have a weak cell up here. It got to 3.6, 3.7 something before this BMS shut down. And the rest of the cells were, I think, at like 3.4, 3.45, I think, something like that. So anyway, I'll have to do some more testing on this one to see what's going on or what its limits are. This one's still charging as far as I know, but you can see this one is dead, or not dead. It's not charging anymore because this guy is measuring the actual battery voltage, yet the Victron's measuring 27.9 there. So this BMS did shut it down, which is good. So that one's full. At least as full as it can be for now. So I'm going to go back and measure the highest cell on this one. to see where we're at. I've been keeping an eye on these. So we're at 3.57. The weak cell on this one got up to just over 3.7, I think, before it shut down. So it's getting pretty close here. But I'll give you an update here in another minute or so. I also wanted to mention that I don't leave these batteries open like this with an open grate up top. That's like I was already say. I've got these foam pads I made that fit in here pretty nicely, and just leave the negative connection to the battery exposed, so that if I did drop anything on there, it just falls on that foam pad. So anyway, and then also I mentioned I'm using this battery charger to get these charged up, but I'm using it to charge all of these batteries to give these guys a nice lower current to charge at. So, you know, it's still charging it. I guess it dropped down now to 34 amps. You can see that. So I don't know, I guess between 4 batteries, I guess it's about 8 amps a piece. So, you know, pretty low charge rate relative to the battery size. So anyway, that's all for now. Okay, so now we're at 3.66 on this highest cell here in this bank of batteries. It's one thing I don't like about these Dali BMSs is, you know, where it says 3.65 is the highest you want to charge these, but you know, I don't know the accuracy of this guy here, but you know, when you look up the specs on these Dali BMSs, they do say they go up to like 3.7, 3.75 plus minus 2 tenths of a volt or something like that. So anyway, I may get another BMS at some point here, but it is what it is. But at least they work for the most part. So we'll keep an eye on this and see what it gets up to before the BMS kicks it off here. Yeah, charge rate's really dropped off, which means it is getting up there pretty full. Nope, dropped down. Okay, must have shut it off. Let's so we got 3.74. So now let's measure the overall battery voltage here. Got 27.92. Yeah, and we're at 28.2. So, yep, BMS shut it off. Okay. So these two guys are full now. Charger has really dropped off. Let's see, that says about 24 amps. Victron here says 21 amps. So, yeah. All right. So what's going to happen now is I'm going to switch over and unplug these 3 banks here down below, and then run everything off of these 2 guys. You know, just I'm gonna run some fridges, you know, lights and everything overnight, and we'll see what the lowest amp hour point we get to. So, okay, I started at amp hours at negative 0.5 amp hours, so that's our starting point. And I just unplugged both these banks with this single positive connection. And then this big battery down here has a circuit breaker on it, so I just flipped that off. And notice the voltage immediately went down to 27.2 back there. So that voltage is still working because it's being powered by these batteries now. It's not powered by this battery at all. So that's why it's still showing a reading. So now right now I just got this shop light up here working off the inverter. So it pulls right at 40 watts. So now I'm gonna turn stuff back on. Lights and outlets here. And then I'm gonna turn our sump pump on. I'm going to turn our kitchen fridge on, so you see it's starting to pull some watts now. I'm going to turn our downstairs fridge on. That usually adds quite a bit more. It's an older fridge, not as efficient. And then, let's see, the amps that's pulling 20 amps out of the batteries. 540 watts, 450, so you can get an idea of the efficiency of the inverter there at that load. So we're pulling 20 amps, that's it's 0.2 C rate, so that's not too bad. I'm going to turn on the furnace here. I don't know if it'll run overnight or not, but it's got the fan on. It'll pull another 50 amps. And then turn the garage. This is the garage circuits, garage doors and lights. That didn't add a whole lot because there's nothing running out there. But so I'll have all that stuff on all night, and we'll see how it does at a 0.2 C rate. Usually when I have everything on like this last circuit here is the heat pump water heater up there. It's basically a refrigeration circuit in backwards. Well, it dumps the heat into the water tank there. I'll talk about that later, but anyway, that's got quite a load on it. So I'm gonna keep it a more decent lower C rate here and see what happens. But when I have all this stuff on except for this heat pump water heater circuit, this normally pulls in the 300 to 600 watt range, somewhere in there, which is what it's doing now. So anyway, I'm going to end it there for tonight, and I'll give an update here in the morning. All right, folks, we're been discharging these batteries overnight, and I woke up at 5 a.m. It's about about 6:15 now, or 5, and the amp hours was only down to negative 100 amp hours. So I turned on a space heater upstairs, so we're down to 174 now, and also powering fridges and other such items. So down to 24.3 volts. I just checked the individual cell voltages in here, and lowest one I found was 3.05 volts, somewhere in there, and the rest of them were in the 3.12 range. So it's they're all still less than 0.1 volts off, but I'm sure that'll increase here shortly. But so these Dali BMSs are 60 amp rated, but I'm pretty leery of that from other videos I've seen. So I've been keeping the amperage, the total amperage between the two, right around 50 or 60, as you can see there. So they're each pulling about 25-30 amps a piece, and they are warm to the touch, but they're not bad. They're maybe 80 or 85 degrees Fahrenheit, something like that. So not too bad. I may push up the current here because sun's coming up and I'm starting to get some solar. So I should probably turn that off, but I don't want to mess up the the logging on those. So I think what I'm gonna do is I'm getting pretty. So I reset the cutoff voltage on this inverter charger to 22 volts. So so far, if you take off a half an amp hour from this, we're doing pretty good. I mean, we're at 176 amp hours capacity so far. So I'm gonna go upstairs and turn up the space heater, and we'll try and get this down a little faster before we get too much solar coming back in. Okay, pull a little more, put the space heater. Oh, looks like the furnace turned on, so that's going to add some load to it. We're pulling about almost a 0.5 C from these batteries now. The BMSs are a little bit warmer, but they're holding in there. These little 10 gauge wires they're getting pretty warm. I don't know, 90 F, maybe 95 F. So the furnace just kicked on here. So I got the furnace, the space heater on high, and fridge is powered. I'm trying to draw this battery down, and it just went below 23, so it's dropping pretty quick. So we'll keep an eye on it here. But oh, sump pump turned on. That dropped it. Okay. Hopefully the sump pump won't turn on here before the end of the test, but we shall see. So when this inverter charger gets below 22 volts, it should be a relay inside there. You'll hopefully we'll hear a click, and this green light here will start blinking. So it's dropping pretty quick. Oh, there's a beep from the inverter charger. It's got an alarm. Oh, it just switched over. So I think the low voltage cutoff time is like 10 seconds. So it, yep, there's the relay. All right, we're blinking now. So we got down to 189.9 amp hours minus 0.5 is point. Hopefully that's focused. Yeah, minus 0.5 amp hours is 189.4 amp hours. Excuse me. So, but again, that's not fully charged or fully discharged. Fully discharged obviously is 20 volts, 2.5 volts per cell. So, and then fully charged is 3.65. And with this battery right here, we only got up to a battery voltage of 27.6 before the BMS cut it off. This cell up here in the far left corner got to 3.7 something, way before the other ones did. So we got a weak cell there, and that one was one of the weaker ones on the downhill side too. So anyway, I call that for getting these things for $175 per kilowatt hour. I believe. Actually, I figured it up. Each with all the connectors, the Anderson connectors, the lugs I bought, the ring terminals for the BMS wires, the BMS itself, all in each of these. The milk crates are free. Already had those. All in each one of these battery banks was $525. So for almost five, I don't know what that is, 190. I'll do that later. Now let's see. 189.4 times what, 25.6 nominal. Four point 4.85 kilowatt hours. So 525 times 2 divide by 4.85. So $216.50 per kilowatt hour. I'd say that's a win in my book. So that's where we're at on battery capacity. I may get a standalone 24-volt inverter to charge to test these each out on an individual basis, but at this point in time, I'd say that's a pretty good, test to get a good idea of where they're at. So anyway, hope you liked the video. I'll be posting some more stuff obviously later on. Always toying around with this system, and we will talk to you later. If you have any questions or want me to test anything else, or any other questions about the system here, let me know. Bye for now. Grace and peace be with you.